So for the first chapter, which is dual nature of particle, we'll be seeing all the four categories of questions one by one. So first of all, for the derivation part, you will only need to see the derivation of stopping potential. There's nothing more than that. There's also one more derivation, that is of de Broglie wavelength, but still they won't ask you the derivative part of it, because it involves some sort of higher physics, which basically is the concepts of that level aren't discussed in your book. So the numerical part would go through in a way where you'll be asked a question from Einstein's equation of photoelectric effect. So that equation where the incident energy of a photon gets converted into the threshold energy, as well as the remaining energy goes into the kinetic energy of the photoelectron. The second numerical would involve the de Broglie wavelength. So basically comparing the de Broglie wavelengths or finding the de Broglie wavelength of a particular particle. So please remember all the formulas that are being discussed of de Broglie wavelength. We will also see this particular concept in the atomic atom chapter also. Discussions. So in discussions part, it will be explaining the photoelectric effect. What is the photoelectric effect, and the experiment related to photoelectric effect, in which you basically take a tube in which vacuum is created, and you have basically have two plates at different potentials, positive as well as negative, and you throw light on the negative plate and you see a current in the circuit. So that proves the existence of photoelectrons in the tube. So that is the experiment you need to look into. So and the second discussion you will need to understand is on work function. So what work function is, or what threshold energy is. So work function and threshold energy, both are same thing. Threshold energy, threshold energy. So basically work function was the term used by Einstein for the concepts regarding photoelectric effect. Now the third concept you need to third discussion you need to read from is particle nature, that is which is being driven from Planck's theory, and wave nature, which is being driven from a de Broglie hypothesis. So both the basic concepts, basic phenomena behind both the aspects, it should be clear to you. Then fourth is Davis and German experiment. So they did an experiment to prove the wave nature of the particle. That is, they made an electron beam fall on the nickel crystal, and they found that the wavelengths that was associated with moving electron hitting a target were equal to the wavelength of X-rays. So they concluded with reference to Bragg's law that every particle like electron also has a wave nature. Then the fifth thing is what is a photocurrent. So that is a very simple concept. Then the sixth thing is, which is very important, all the features explained by Einstein equation about photoelectric effect. So this is very important. So you need to know the basic physical phenomena that are being explained by Einstein's equation. Then graph from this chapter are important, because there are graphs and that are not being very nicely explained in NCERT. So you need to understand the outline points to be remembered upon for every graph. So basically all the graphs on photoelectric effect. So the first graph is intensity versus photocurrent and potential plotted in same graph. So there will be there will be current versus potential plotted in the same graph for different intensities for same material. So this is the first graph. The second graph is stopping potential versus frequency by Einstein equation. So Einstein equation, when you compare it with a equation of a curve, so that curve comes out to be a line. So when you compare Einstein equation, it will show you the equation of a line. So you'll break it into a general line, a general form, that is y is equal to mx plus c, and you'll find that you'll get a line with some y intercept in the negative direction. So you'll see that the third graph is intensity versus current versus potential. The graph is again the graph is again uh, for same intensity of light, uh, uh, and plotting potential and current against each other, but for different materials. So there will be three different materials and the light intensity of light will be same, the frequency of the light would be different, or you can say that for different materials the main thing which is different is the uh, threshold frequency or the threshold energy. So these are the things you need to cover for this particular chapter. So please go through all the concepts, derivations and numericals one by one, and you'll definitely score full marks from this chapter, because these parts are easy compared to other parts of 12th class.